This is lesson 33 of Algebra 1. We're talking about products of prime factors, and I'm going to do it a little bit differently than they do it in the book. Okay, but you're going to get the same answer, and it makes more sense to me this way, but you're kind of doing the same thing. It just looks a little different. Okay, so I am going to find the prime factors, or all of the prime numbers that when you take them times each other, they're going to equal 80. Prime numbers are things like 2, 3, 5, 7, 11. So remember, prime numbers are numbers where you can only take that number times 1 to find the answer. So like 2 is only 2 times 1. You can't take anything else times itself to get 2. You can't take 3 times 1 is the only thing that works for 3. Okay, 5 times 1 is the only thing that works to find 5. Okay, those are the only factors of those numbers, 1 and itself. So we are going to start looking right here at 80, and we're going to say, okay, 80 is what number times what number? And you can have any two numbers that equal 80. So I'm just going to pick 8 and 10. Okay, so 8 times 10 equals 80. If those numbers are prime, then we're all done. But 8 and 10 are not prime. So we're going to break them down even more. So we're going to say this is 4 and 2. 4 times 2 is 8. The only number that's prime, though, is 2. So we're going to circle it. 4 is 2 times 2. Those are prime. So now we have 3 2's that are prime. And if you see here, 2 times 2 times 2 is 8. That's that little branch of this tree, okay? So then 10 is 5 and 2. This is prime, and this is prime. So now we can't go any further. We can't make any more little branches to our tree. So we have a 2, a 2, a 2, a 5, and a 2. Okay, so we are going to write that down as this. 80 equals 1, 2, 3, 4. 4 2's and 1 5 is thrown in there. So this is kind of what they're looking for, this answer, 2 times 2 times 2 times 2 times 5. That is the product of the prime factors for 80. You can do this for any number that you want. You just start at the top, find two numbers that when multiplied equal that top number, and then you just keep breaking it down into branches until you've got only prime numbers left. Okay, so the other half of lesson 33 is a little bit trickier to kind of explain without walking you through these examples. So instead of writing it all out, we're just going to look at it. So let's look at example 33.3 on page 135. It says, twice a number is 42 less than 102, the opposite of 102, or negative 102. Find the number. It says we must be careful because the problem tells us about things that are not equal. We begin by writing an equation that we know is incorrect. Now, you can do this, but if you can figure out how to do it yourself, I don't care as long as you can get the answer. But this is how they go about the problem. So they say twice a number is negative 102. And so they take out this is less than part, and they just write 2n equals negative 102. Now, that's not actually what they said. They said that 2n is 42 less than 102. So we need to do one of two things. We either need to take 102, negative 102, and subtract 42 so that it's smaller, or we do the opposite of it, like let's say that we added 42 to both sides, then this 42 gets moved over here, and suddenly it becomes 2n plus 42 equals negative 102. So if you had this written down, that would be fine, and if you had this written down, that would be fine. You can still find the answer to your problem given those equations. Here's example 33.5 on page 136. It says if the sum of twice a number and negative 14 is multiplied by 2, so right here is twice a number and negative 14. It's the sum of that, okay? If the sum of twice a number and negative 14 is multiplied by 2, that's where you get this equation, the result is 12 greater than the opposite of the number. So the opposite of the number becomes over here, the other part of your equation. Okay, so 2 times 2n minus 14 equals the opposite of the number. But they are saying that this result here is 12 greater than that. So we need something that's 12 greater than that. So we either need to negative n plus 12, which is what they did right here. So you've got your 2 times 2n minus 14 equals negative n plus 12. Or you shift your negative 12 onto this side, and you make it 2 times 2n minus 14 minus 12 equals negative n. You're going to get the same answer no matter which way you do it. Now, they like to start with something that is incorrect, and then you figure out the greater than or the less than, and then you add it in later. That's what they are doing in these examples, and you can walk through them if you would like, but it's a little bit tricky, and sometimes you think, wait a minute, does this make sense? But you just follow the same procedures that we've been working on. Let's look at example question A from your homework, page 136. It says, find a number such that 8 times the number is 36 greater than the opposite of the number. So here's where we're writing a statement that is not true. We took out the 36 greater than part, and we just wrote down 8 times the number is the opposite of the number. Okay, so then we have this 36 greater than. So it says find a number such that 8 times the number is 36 greater than, 36 greater than this number. So 8 times n is 36 bigger than the opposite of the number. Okay, so now we can solve our equation. (9n equals 36. Divide both sides by 9, and you should get n equaling 4.